Thanks for joining us. I'm Beth Jones.
And I'm Peter Dubois. It's been over 60 years since Maine has experienced a total solar eclipse, and this April 8th, Mainers will have the chance to see this rare event.
ABC 7 and Fox 22 is your home for the Maine eclipse, and to learn more, we've teamed up with Sean Latt, director of the Versant Power Astronomy Center and Jordan Planetarium at the University of Maine. And that's to give you a better understanding of just how eclipses work and why you shouldn't miss this one. Sean.
Thanks for joining us. Today we're going to be talking about the April 8th total solar eclipse, the first time Maine has had a solar eclipse since 1963. Solar eclipses happen when we have the sun, the moon, and the earth in a direct line, and the moon is casting a shadow on planet Earth. Now this can only happen at the new moon phase of the moon, and we get basically two different types of shadow. We get the umbral shadow, which is the deepest part, and if you're inside that shadow, that's when you get to see a total solar eclipse, one of the most spectacular sights in all of nature. If you're on the either side of that, in the penumbral portion, the outer portions of the shadow, you will get a partial solar eclipse, and that actually covers a much larger area of the Earth. So on April 8th, when we have our total solar eclipse here in Maine, the entire state will not get totality. You will have to be within that dark umbral shadow to be able to see it. Places like Jackman and Holton and Patton are along that path. Places like Bangor, Orono, Vesey, Augusta, Portland, they're not. So they'll only get a partial solar eclipse. So it really does matter where you are and at what time to be able to see a total solar eclipse. We don't get eclipses every month, of course, because the moon's orbit doesn't always line up perfectly with, of course, the sun. So every month we have a new moon where we do have the sun, the moon, and the earth, but oftentimes that shadow is either above or below the earth and isn't casting directly onto earth. But when we have that special alignment, when it does line up perfectly, that's when we get an eclipse. The most special, of course, are the total solar eclipses, and this is when the moon completely covers the sun and it allows us to see the corona, the atmosphere of the sun. This is this very thin, ethereal sort of area, 1,000th the brightness of the regular sun. And the only time it is visible is during a total solar eclipse. Total solar eclipses are one of the most spectacular things you will see in all of nature. And I've mentioned this oftentimes, I say this, but it is so true, and that is that the difference between a partial and a total is like the difference between seeing a lightning bug and getting hit by lightning. It really is that dramatic, so I highly encourage you to try and see this total solar eclipse on April 8th of 2024. Now, totality is a relatively short thing. Total solar eclipses can last from a few seconds up to about 7 minutes or so in length. And the one here we're in Maine we're going to have is going to be about 3 minutes and 28 seconds of totality. Partial phases, however, last a little bit, about an hour or so before and an hour after. All right, so you're going to start with that partial eclipse all the way up to totality, then you'll have totality, then of course another partial as the eclipse finishes. During totality, you're going to get this really amazing view. It's almost going to look like there's a black hole in the sky. The colors of the sky are really weird. It's not completely dark, but it'll get dark enough to see brighter stars and brighter planets. You also have this twilighty effect around the horizon, and shadows are really weird. Again, the sky's going to be almost a silvery or steely blue color. Temperature will drop a few degrees typically, and even birds and animals pay attention. Sometimes you'll hear a rooster crow, or you'll see animals quieting down, because again, they're very confused by this. But it is really one of the most spectacular events you'll see in all of nature. Now, solar eclipses, of course, are the really special ones and really exceptional, but we also have lunar eclipses. Most people see several lunar eclipses during their lifetime, and the reason is that during a lunar eclipse, which can only happen at full moon, the moon is passing through the Earth's shadow. And again, this doesn't happen every full moon, but when there's that perfect alignment, it will pass through the Earth's shadow. That eclipse is visible from the entire nighttime side of the Earth. So unlike a solar eclipse where you have to be within that shadow path, which is only about 175 miles wide or so, the entire nighttime side of the Earth will see a lunar eclipse. Lunar eclipses also last much longer. Totality can be up to an hour, and you end up having the partial phases be about 2.5 hours on either side. So you're looking at a 5.5, 6 hour event for a lunar eclipse. So again, here in Maine, we're going to have totality on April 8th, but it's not the entire state that gets that. So again, it's really important to where and when you are looking at the eclipse as to what you see. So we've talked a little bit about how eclipses happen and why they happen in terms of the positions of the sun, moon, and earth. And now I'd like to talk a little bit about why eclipses are really important and sort of spectacular, if you will, both in terms of a variety of history and culture, and the science discoveries that happen during solar eclipses as well. If you're not expecting it, it can be quite a scary event, if you will. So, ancient people often feared eclipses, and there's numerous stories and cultural references to eclipses over time. The Chinese thought that there was a dragon devouring the sun, and they would actually make noise with pots and pans and set off fireworks to try and chase this dragon away. It always seemed to work, after a few minutes anyway, and the sun would come back. Chippewa Indians shot flaming arrows at the sun to try to rekindle it because they thought it was burning out, and they were very scared that this, again, the source of all heat and light, was burning out. So lots of different things, of course, around eclipses, and lots of different cultures have different stories about them and why they were happening. But also, eclipses played an important role culturally in other ways too. If you were an astronomer in ancient China, that was a very important position. And if you accurately predict when a solar eclipse took place, you got your weight in gold. However, if you failed, you lost your head. So it could be really beneficial to really understand how eclipses work. So in addition to some of the stories about them, we also know that people kept track and observed eclipses over time. Stonehenge, which most people are familiar with, is actually an ancient astronomical observatory. You would stand inside the center of the ring and sight out through the three-sided henges, or stone gates if you will, to watch the rising and setting positions of the sun and moon. And from this, they were able to figure out a portion of the Saros cycle. This is a cycle that governs when we have eclipses. They also could determine the seasons, of course, the solstices and equinoxes, but Stonehenge was basically used, and we know that ancient people were able to figure this out. The Babylonians also kept track of eclipses and created very elaborate tablets. In fact, up until probably the 1980s, their tablets were so accurate they were using them to correct computer predictions of eclipses. And again, they were feared in some cases. There even was a case in around 585 where the Medes and the Lydians, two Middle Eastern countries, were battling each other at the time. A total solar eclipse happened in the middle of the battle. Both sides were so freaked out that they stopped and signed an armistice. So, I don't know if that'll happen in this next one, but one can be hopeful given some of the things going on in our world right now. But there's also been a lot of great science that takes place during eclipses as well. It was during a total solar eclipse in 1868 that the element helium was first discovered. Helium from the Greek word helios, meaning sun, and it was looking at the corona, the atmosphere of the sun. Spectroscopy had just been developed, and helium, of course, is an element that you might know from helium balloons, but it moves so fast that it can reach escape velocity in our atmosphere. But using, of course, spectroscopy, they were able to look at the corona of the sun and discovered this new element, helium. Of course, a very famous prediction that was made and then verified, and has been verified several times since, is Einstein's theory of relativity. Einstein had accurately predicted the amount of shift that would take place. And so this eclipse in 1919 allowed them to make this measurement and verify that Einstein was right, and it proved the theory of general relativity. Today, we use total solar eclipses to help understand the corona, the atmosphere of the sun, which is the starting of the solar wind, which bleeds out and affects our solar system in a variety of different ways. The solar wind impacts us here on planet Earth, and it interacts with our magnetic field, and occasionally, when we have huge solar storms, we'll get aurora borealis, the northern and aurora australis, the northern and southern lights, of course, as we call them, in our atmosphere because of that. And of course, there's a variety of space weather that we have to keep track of today because it can influence our satellites and our astronauts when we send them out to places beyond low Earth orbit. So understanding space weather and the workings of the sun is very important. That's one of the pieces that solar eclipses are still doing today. And actually, here at the Planetarium, we're taking part in an event like this. We're working with the Continental American Telescopic Eclipse Group, and we'll be setting up stations within the path of totality for this 2024 eclipse, collecting data on the corona of the sun using polarized cameras.
Thanks, Sean. We'll be back with more on the main eclipse right after this.
We've talked a little bit about the science and how and why eclipses happen, We've also discussed a little bit about their cultural and scientific relevance. Now we want to get into something that's exceptionally important, and that is eye safety. We want everyone to see this eclipse, but most importantly, we want you to observe it safely. One of the best things you can do for viewing the eclipse, and that is required or needed really for all of the partial phases, are using solar eclipse glasses. These are not sunglasses. They're made of a very special material that blocks out 99.9% of the sun's light. They allow you to safely observe the sun. If you look up or look at anything else than the sun with them, you won't see anything because they're exceptionally dark. Again, they're specially designed to keep your eyes safe. Now, the sun is no more powerful on a day of an eclipse than any other day of the year. And you should never stare directly at the sun because you will damage your eyes. But on a solar eclipse day, people do want to look at the sun and they do want to stare at it because they're trying to see what happens. But again, if you're not wearing eye protection, you can do damage. Your eye doesn't have pain receptors, and that's one of the reasons in terms of the retina doesn't have pain receptors, so that's one of the reasons you can burn your eye without knowing it. So please, please use proper protection. These are really great, and again, they're very reasonable. Typically, you can get them for about $2 a pair, and they will protect and keep your eyes safe. If you've had these for a few years, it's good to replace them. They're good for, 3-4 years, but beyond that, you really do want to replace them. Do check them beforehand, make sure you don't have any pinholes or any scratches on the surface of them, and then you'll be good to go. So this is one way to do it. Now, another way you can do it is doing some indirect viewing, and that is to build basically a pinhole projector. And a pinhole projector, what you're going to be doing, and I have an example of one here, basically you have one end that you've cut a hole in the box and you've covered with a piece of tin foil. You put a hole in it. On the opposite side, you put a piece of white paper. Now, you're going to stand with this particular object so that the sun is behind you. So again, you're not looking through the pinhole, you're projecting an image onto that white sheet of paper. So you stand with your back towards the sun, you move around until you get a pinhole image of the sun inside this box. And you can watch all of the partial phases. Again, this is for seeing the partial phases, just like the solar eclipse glasses for the partial phases. It's the safest method because you're not looking at the sun at all. You're looking at a projected image. If you're standing underneath a tree during an eclipse, you might actually see it project through the leaves on the tree. I've seen people take a colander or even poke the holes in a sheet of paper saying like Eclipse 2024 or their name, Jack and Annie in Eclipse 2024, and standing with their back towards the sun and letting it project through on the ground. It can be kind of cool and something fun to do as well while you're watching those partial phases, which again will last a little over an hour, so you have plenty of time to play around a little bit with that. This is a special telescope for viewing the sun. It can be used during an eclipse day, but also on a non-eclipse day. This device basically you set up and you allow the sun to shine through. You're not going to be looking through it, but it's going to shine through. It's going to hit a number of mirrors and it's going to project an image down here. You can watch the partial phases. You also can use this to see sunspots. These are a little more expensive. They run, the last time I checked, they ran about $500 a piece. But again, they're a very safe way and a number of people can use them at the same time. But they're called sun spotters. That's another safe way to view. If you're using telescopes, the key thing is that you have a glass filter that covers the entire front of the telescope. And I highly encourage folks, you can get these in either Mylar or glass. If you can, get the glass. They're only a little bit more expensive, but they're much better. The reason I say that is Mylar can get a pinprick or can get scratched. Glass ones are very sturdy and will last much longer and are much safer. But you need it to cover the entire, basically, objective, the largest diameter of the telescope to keep your eyes safe. And then you can see this. Again, this would be used for all of the partial phases of the eclipse. During totality, it is safe to look at the sun, and we want you to because, again, during totality, you want to look at it because that's when you'll see that corona, the atmosphere of the sun. It will look like there's this hole in the sky, and again, it is one of the most dramatic things you will see. Some folks even will use binoculars or a telescope to look at that. Just make sure that you're definitely in totality because you don't want to damage your eyes. Now, one of the advantages of going to some place where there are either astronomy educators or planetarium directors or astronomers on site is there typically will be a countdown. And you'll sort of hear this towards the beginning of totality, 9, 10, 9, 8, all the way down till now it's total. And you know to take your glasses off. know you can take your solar filters off, and then all of a sudden, as soon as it starts, it'll feel like it's only been 5 or 6 seconds, even though it might be several minutes, but then you'll hear this 5, 4, 3, 2, and then all of a sudden it's over. Again, remember that shadow is moving close to 1,200 miles an hour. So it happens very, very fast, and those few minutes, again, they seem to just go by exceptionally fast because it is so strikingly beautiful. But again, the key thing is eye safety. Keep your eyes safe. Be safe about viewing the eclipse because, again, your eyes are very important for most things you do in life. So we just want people to be safe, take care of their eyes, and view this eclipse safe. If you stayed on one place on the Earth and were trying to see a solar eclipse, in general, you'd have to wait roughly 300 years between solar eclipses on the exact same point on the Earth. Now, that being said, you might think, well, eclipses must be really, really rare, but not that rare. Total solar eclipses happen on average about every year, year and a half, but you have to be in the exact right place at the exact right time to see them. Why do we see eclipses when we see eclipses? Well, there's this thing called the Saros cycle. The Saros cycle is a cycle that's 18 years, 11 1/3 day. Every month, of course, the moon orbits the Earth. It takes 29.5 days from full moon to full moon. However, the moon's orbit is tilted to the Earth. And because of that tilt, that's why we don't get solar eclipses and lunar eclipses every month. But that tilt crosses that path where it does line up directly twice a month. Those are called nodes. But the nodes have to be taking place at full moon or at new moon to have an eclipse. Here in Maine, again, there are a number of eclipses. I wanted to give you an idea of how often we get eclipses, even here in Maine. So April 8th, of course, of 2024 is the next total solar eclipse and the next eclipse. On the 17th and 18th of this year, we get a partial lunar eclipse. The 13th and 14th of 2025, that's when we're going to get our next total lunar eclipse. And then we have a partial solar in 2025, a total lunar eclipse in 2026, and another partial lunar in 2026. So you can see there's a number of eclipses that happen in Maine over the next several years, but again, they're not a total solar eclipse, which is the most dramatic and most spectacular. So April 8th, you do want to check out this total solar eclipse. The one that's happening this time starts off out in the Pacific Ocean, comes up through Mexico, up through Maine, and goes off into the Atlantic past Canada. You might notice some of these shapes to these paths as well. And what I'm going to call your attention to is the path here, which was March 29th of 2006 and April 8th of 2024. This upcoming eclipse is kind of special to me because the 2006 eclipse, I was in Libya for that total solar eclipse and had a chance to watch it. And it was the first solar eclipse I took my wife to. We had just been married a few years earlier and got her really excited about eclipses when she saw it. As you might notice, those paths look the same. That is the same Saros. Solar eclipses can happen anywhere on the globe, but again, you have to be in a very specific place and time. 2001, 2019. Again, that 18-year, 11 1/3 day cycle. Here's a map of eclipses coming up basically from in the next several years, probably the next 4 or 5 years. But these are both annular and total. The red ones that you're seeing are going to be the annular ones. Those are the ones that have the ring of sunlight. And the blue ones are going to be, of course, the ones that are total solar eclipses. And again, if you miss this one, the next total solar eclipse that's going to happen after 2024 is going to be in August of 2026. Here, to give you an idea, are the paths of total solar eclipses coming up over the next number of years. May 1st of 2079 is the next time Maine gets totality. That time it actually will be right along the coastline. But the big one, of course, that we're most excited about, the one that's coming up, April 8th of 2024. Again, you do have to be in that very specific place within that dark umbral path. You can see from the map that basically you have the rest of the United States gets a partial solar eclipse in some way, shape, or form. But the farther away you get from that path, the less, again, of the sun is going to be covered by the moon. In terms of this eclipse, because the moon's orbit is elliptical, like I showed you, and that changes its position, Mexico and Texas actually get about a minute more totality than we get here in Maine. Their weather prospects actually are also a bit better. However, we're going to do our best to see the eclipse here, and I do hope you get out and have a chance to see it here in Maine.
Thanks, Sean. Coming up, we'll hear more from him about totality and why it's so special, what to expect, and why you shouldn't miss it.
Stay with us.
So hopefully by now you have marked April 8th of 2024 on your calendar for this really exceptional total solar eclipse. The first time we've had totality here in the States since 1963. A total solar eclipse, again, is where you're going to get to see the corona, the atmosphere of the sun. Again, it's going to look like there's a hole in the sky where that eclipse is, and you'll see that beautiful corona around it. Temperature is going to drop a few degrees depending on where you are. Particularly if you're in a desert area, you'll really notice that drop in temperature. But even in Maine, you'll probably notice it. And birds and animals will pay attention. The winds typically will die down a little bit, so it really is one of these things. And if you're in a group, you're going to hear lots of whooping and hollering because people get really, really excited about these things. Again, they're really spectacular. And the first time you experience it, you might even have a little bit of that tinge of fear. And why is the sky getting dark in the middle of the day? But it really is one of the most spectacular things you will see in all of nature. You owe it to yourself to get out and take a look. Again, because if you miss this one, 2079 the next time it will happen in Maine. Now, you have about an hour before and after. Take in the whole scene, if you will. Take a look if you're near a tree. Look beneath that tree to see, again, partial images of the solar eclipse being projected through leaves. You know, make yourself a little memento by poking your name and the date in a sheet of paper and letting it project on the ground with the eclipse. Use that time. Watch for shadow bands, which happen just before the eclipse, which are little bands or waves of shadows that you'll see on the ground. And again, the corona, this is the atmosphere of the sun. The only time we see it is during a total solar eclipse. That corona is about 2 million degrees. To give you an idea, the average surface temperature of the sun about 10,000 degrees Fahrenheit. Corona is over 2 million degrees. Again, it's very thin and ethereal, but it's the start of the solar wind. And it affects, again, as I mentioned, spacecraft here on Earth. It affects, space weather can affect us in creating those aurora borealis and aurora australis, the northern and southern lights. And we're still trying to do some research to understand more and more about that. Most people, again, only will see one or two total solar eclipses during their life, unless they're willing to travel. Really, photographs and videography doesn't do it justice. In fact, I tell people, if this is the first time you're going to see a total solar eclipse, do not photograph it. Look at it, watch it, observe it, take it all in, because it's not just the eclipse, it's everything that's happening around it. It's the color of the sky. For instance, this is a picture from the 2017 eclipse before and after. Same photo, you can see it really got dark. Did it get completely dark? No, again, it's going to be twilighty, but the color of the sky and shadows are going to be really sharp. And again, the color of the sky is really this eerie, steely blue or silvery color. It's really sort of an eerie feeling. But you do need to be in the very specific place to see that total solar eclipse. If you're on either side of the line, you'll only see a partial. So we do want to make sure you get to see the total solar eclipse. Now, the best places to be, again, Jackman, basically, Mount Katahdin, Holden, Pat, areas like that. This is the deepest portion of the eclipse path, where you'll get that full 3 minutes and 28 seconds of totality. Now, you'll still get a total solar eclipse from Lincoln or Milo or Guilford or Dover Foxcroft, but they're just barely in that path, so you're only going to get a few seconds. You might get 15 or 20 seconds of totality there. So if at all possible, try to make it to the center line where you can get up to 3 minutes and 28 seconds. For Jackman, for instance, that eclipse is going to start around 2:18 in the afternoon. Totality will begin at 3:29 and 29 seconds, and totality will end at 3:32 and 52 seconds. So again, very distinct timings. So it's very important where you are that you look up what time the eclipse starts and ends, and particularly the totality phase, because that's the time when it's safe to look at the sun with your unaided eyes, is during totality. So you want to make sure you know those timings very specific. So again, this is really a special event, and you do want to catch it. And I hope it's special enough that you'll get out and take a look at it.
To learn more about the upcoming eclipse, you can click on the Main Eclipse button on our website, foxbangor.com.
This will connect you to the Versant Power Astronomy Center, which has all kinds of useful links and interactive maps about the upcoming Maine total solar eclipse.
Stay with us for continuing coverage of the Maine total solar eclipse.
And thank you for watching ABC 7 and Fox 22.